Hello again, this is Bumpton with a visual functional mathematics at level 1, and this time we're going to start with section 3, data handling. Data handling is about processing data, storing data, and then converting data into information that could be used for decision making. You got information in the form of charts and graphs, and of course you got tables that information users need. The challenge is to make sure you present the information in the way they prefer it to be. In today's lesson, we shall deal with tables, charts, and graphs. And your learning objectives include to create a table for storing data, using table to store information in columns and rows, making tables from a set of data, extending tally tables by adding a frequency column, making charts to show the distance between different places, and using bar charts to compare data. The keywords and phrases you need to be familiar with are table, row, column, data, information, location, distance, and chart. As I usually advise you, you need to be familiar with these words and be able to use them fluently in maths. We start with tables. Tables are a way of showing information. They show information in columns and rows. This table on the right holds information about two different televisions, TVA and TVB. It tells you the screen size, HD specs, colors, and prices of each make of the TV in the table. If you look on the image on the right, the table has row headings and column headings. The column on the right, please watch the arrows, runs from top to bottom, and the rows runs across from left to right. Mileage charts give the distance between places. Mileage charts are a kind of table. They tell you the distance between different places, but you need to know how to read them. The example you see here, use the mileage chart to find the distance between Blackpool and Sheffield. To do this, you need to move down the column beneath the Blackpool headings and across the row next to Sheffield heading. Where the columns and the row meet is the distance between the two places, which is 92 miles. Example 2. Use the mileage chart on the right to find the distance between Blackpool and Sheffield. You will see that the table has two sets of headings, one column heading and another one row headings. Where they meet is what you're looking for. By that I mean, to find Blackpool on one side of the chart and Sheffield on the other, move across the row and down the column to the square where the row and the column meet. The distance is 92 miles. It doesn't matter where you start looking, whether it's from the row or the column, you get the same result. Practice questions, set 1. Use the mileage chart below to answer the following questions. Distance are shown in miles. A. What is the distance between Milan and London? B. what is the distance between Bognor Regis and Edinburgh? And then C, Jinden is driving from Edinburgh to Milan and then driving to London. What is the total mileage of his journey? In this case, you will have to add 2 miles, but you have to find them correctly on the table. And here is your answer. Question 1A, 292 miles, B, 456 miles, and then C, 458 miles. Check your answers. Where you go wrong, find out where you went wrong and make your correction. Let's look at tally charts and frequency tables. You can use a tally chart and frequency table to show how many. You can also use a tally chart or a frequency table to put data into different categories. For example, this tally chart shows the colors of cars in a car park. If you look on the left, down the column, the color column, you will see there are 2 blue cars, there are 3 red cars, there is 1 green car, there are 6 silver cars, and there are 3 white cars. The column headings are color and then tally. You see the little strokes there? Each of those strokes on the tally represents 1 car. And the way you use it is, when you have 4 strokes, that's fine, but if you have a 5th stroke, you put it across the strokes to make it 5, and then you start again. The row of the silver car is showing that there are 6 silver cars in the car park. All you need to do is add 5 plus 1 and you'll get 6. Tally charts and frequency table. The table on the right in this diagram is the tally chart, and then a frequency table is added to make it easier to understand what the information is about. You can add another column to make the chart into a frequency table. You will fill this in by adding up the tally marks of each color. Check the frequencies. The total should be the same as the number of tally marks. So it's important that after you've completed your frequency table, you check the total on the frequency table with the tally. They should be the same. In this case, 15 cars in all. How do we make a table for a set of data? Let's follow this example. First of all, the instruction says you might need to design your own table to collect or display data. There isn't just one right way to do this. It all depends on what data the table needs to show. Make sure to include rows and columns for all data and enough space for everything that needs to be put into the table. Check it again after you've drawn your table. Before you can do that, you have what we call the specification, which tells you what is required. You need to read that very, very carefully, understand it before you start. Example, Laura is organizing a dinner party for 8 people. Some of her guests have special diets, and the special diets are gluten-free and nut allergy. Design a table to show each guest's diet and the total number of guests that have each type of diet. Some guests do not have a special diet. Show this as well. So the table could look like this. Let's start from the column heading. You have diets, you have guests, you have total. And then at the top there is space for each of the 8 guests' diet to be shown. Each guest's initials can be written in the top row. So if you count under guests, you'll see that there are 8 spaces for the guests. And then on the left you have diet. So all you need to do is look at who wants gluten-free or nut allergy or no special diet, and you put their names against it under the guests. And then on the total column you add them up, so you'll be able to have your answer correct. The type of diet for each guest can be shown by putting a tick next to the diet type. Include space for all the information. You're asked to include the total number of people with each diet, so there needs to be somewhere to show that. Creating a table requires a lot of effort and understanding of what you're asked to do. But once you've done the table, it's one of the most efficient tools you can use in data collection and processing. Here's an example of a specification for a table. Terry is an electrician. He needs to place an order with his supplier. Design a table that Terry could use to record the details of the order. The table should have space to record what items he is ordering, the number of each item he is ordering, the price of each item, and the total costs of the order. In this case, you have to identify the columns. The rows will indicate the number of items, and then the columns will tell you the specification of the items he's ordering. Let's see what the answer is. This is an example of what you're required to do. You're not going to fill it with anything yet because you need to get it right first. So you draw your table, and the column headings are the items, the quantity, the price, and the total cost of item. And then under price, you put your total. There are other ways of drawing this table. Just make sure you've left space for all of the details you are asked to provide for. Charts and graphs. Bar charts let you compare data easily. A bar chart is a simple way of showing information, as I said. On a bar chart, you plot your data using two lines called axes. If you're talking about just one of them, it's called an axis. So it's not a plural or singular, it's just the name, axis. And here is more information about it. Look at the diagram at the top. On the left, you have axes are labeled to show what they represent, which is day of the week. And then you have vertical axis. You have on the right, the title describes what the graph is showing. So this is a graph, a bar chart, which a graph is to show the number of days Steve worked in a week. And then horizontal axis, at the bottom there, it tells you the days of the week. So for each day, it tells you the number of hours that Steve works. So let's look at the description. The height of each bar shows how many hours were worked each day. Number 2, just read across from the top of the bar to the number on the vertical axis. For example, Steve worked 3 hours on Thursday. You can draw a conclusion from the chart. For example, Steve worked the most hours on Wednesday, as it's the day with the tallest bar. So you see, rather than reading a whole load of data or numbers and figures, all of those can be organized in a bar chart. And at a glance, you can make decisions using that bar chart, like the day that he worked the most, and in that respect, the day that he did the least hours, which looks like Monday and Friday. Practice question set 3. The bar chart shows the number of different colors of shirts that were sold in a shop. A. How many blue shirts were sold? B. Which color was the most popular? And then C. How many shirts were sold together? All of these information can be derived from the bar chart you're seeing on the right. Look at it, study it, and answer the questions. And those are your answers. Question 1A, 3. B, yellow, and then C, 15, the total. You also have line graphs. Now, what is it good for? Line graph shows the relationship between two things. It can be used to show how two lots of data are related. For example, here is a line graph for changing temperatures from degrees Celsius to degrees Fahrenheit, or the other way around. What is 35 degrees Celsius in degree Fahrenheit? 1. From the 35 degrees Celsius on the vertical axis, move across until you get to the line. Which means you need to understand what the line is giving you. Right? On the vertical axis you have degrees Celsius, and then on the horizontal axis you have degrees Fahrenheit. The straight line across shows where they meet, and that is the conversion. The value on the horizontal axis is the answer in this case, which is 95 degrees Fahrenheit. So 35 degrees centigrade is equal to 95 degrees Fahrenheit. Let's look at practical question set 4. Here is another graph which can be used to change between miles per hour and kilometers per hour. Look at the vertical axis, look at the horizontal axis. The intervals are 10, 20, 30, 40, 50, 60, 70, 80, 90, 10s. And then going up again, the intervals are 10. What is 50 miles per hour in kilometers per hour? C. What is 25 kilometers to the nearest miles per hour? And then B. What is 40 kilometers in miles per hour? And there's your answers. Question 1, 80 kilometers. B, 25 miles per hour. And then C, 15 miles per hour or 16 miles per hour. That is not certain, but at least it gives you a reasonable idea of the conversion. And that's your lesson. Let's look at what we've learned. As usual, make your notes first, summarizing what you got from the lesson, and then compare it with mine. You cannot go wrong. You now know that tables are a way of showing data. Tables contains rows and columns that contain the details of records. A chart is a kind of table. Tally and frequency tables are used to count how many of something. Tables can be extended to include frequency, and then charts let you compare data easily. We also know that line graphs show the relationships between two things, as we did in the cases of Fahrenheit and centigrade, miles per hour and kilometers per hour. And that is your lesson for today. I hope you enjoyed it. Go through again and make sure you are happy with everything